Okay, so I am back, and I think today my aim is to get some hex grid functionality happening. I forgot to mention in the last video, but I made a few changes, hopefully to make things sound a little bit better. I had a very lovely friend of mine lend me his microphone. So it'll be a little bit less background noise, hopefully, than previous times. And also last time I heard that the mouse clicking was a bit loud, and that was because my mouse was literally right below my microphone. So I've moved my microphone to the other side, and hopefully that makes a difference. And lastly, I also I upped the quality in the last episode I uploaded. Originally I had it set for some reason to streaming settings, so it was at a very low resolution, but I'm recording the videos, so I've changed it to something that's a little bit more readable, so hopefully that makes the code easier to read. Anyhow, without further ado, so I'm going to be using a few sources to help me on this journey of trying to make working grids. And if I just drop over to my, something's not right, there we go, this is my browser, and so there's this amazing website by the Red Blob Games at redblobgames.com, which is just all about how hexagon grids can be implemented in video games. A lot of very amazing and helpful content, and it has a bunch of pseudocode, which is I'm going to be working off, with some very, very handy and useful interactive widgets, and it makes it a lot easier to understand. And then of course I'm going to be using olcPixelGameEngine again, because I love its simplicity. I'll probably be switching over to some other game engine or framework once I actually want to start making a game out of it, but I thought for the time being I wanted to get used to this, and it's good for C++, so I'm going to use this for the time being. So here is the, on GitHub there is a bit of a wiki. This is David.x9, who's made this amazing framework, and he has a nice wiki on his GitHub page. So that's what I'm going to be using these two sources as reference as I'm embarking on this journey to make hexagon grids. So let's get started. Now I'm still getting used to the basic shape of format of this framework, but it starts with, of course, including it. So hashtag include olc pixelgameengine.h. Thank you, VS Code. And then I don't fully understand why this is the case, but you have to define olcPG application at the top, otherwise it does not work. I had to find that out the hard way. So after that, I've just got to make a class for the LC engine. Oops, that's not Hexagon engine. LC engine. Let me try and remember how the syntax was like. Still getting used to C++ as well, so doing a lot of things at once here. Alrighty. Public LC namespace, and we want the pixel game engine, and then we can open it up. And first we want to define a public. In the public we want to define the constructor. So I will see, actually what do we want as the type? We don't need it. Engine, and open. And then sapp name, and then this is where we set the name of the application. So I'm just going to call it hex demo. And that's that. Then moving on, we have, first, funny, I think at the end of whenever you're making classes as structs, you have to put a semicolon after this bracket. Yay, no longer errors. Alrighty, and now we want to do some more public. In all of the examples he gives, he declares two different publics. He declares public more than once, and I'm not quite sure what the reasoning is behind that. But I'm just going to follow that for the time being. So here's public again. I will like to try without it though and see if it still works. So we're making an onUserCreate. In this framework, there's two basic functions within the class, which does basically all the where we put all of the main code of our game, and that's onUserCreate, which is like the constructor, but it's a separate function, and I guess it incorporates a bit more into it. And that's just called once at the beginning when it started. That's pretty standard. So we can declare anything we need for the duration of the entire game there. But then there's also a function bool on user update. And this one is the one which runs, and we want to overwrite that, which runs every single frame. So any kind of update logic or yeah, anything that updates, and also drawing things to the screen we'll do in here. I've just been doing some weird shenanigans there, don't mind that. Alrighty. So we just want to return true for the time being there, and we can fill that up later. It's causing a problem here. Have I written it wrong? I need to put it, I'm forgetting to put an argument in here. There's f elapsed time. I guess that just tells the function how long it's been since the game started. And I'm obviously spelling something wrong. No, it looks correct. I'm just forgetting to define it as a float. Float. There we go. Errors be gone. Hey, they went away. How kind of them. Alrighty, so that's it for defining our function. And then we've just got to make the entry point for our program in main. And now we can make an object, an instance of our olcEngine, which we derived from the PixelGameEngine. And we'll just call that demo. I'll just steal the name from the wiki. If demo.construct. And then this is where we chuck in our size. I'm just going to choose something random like 400 by 400, and then I have to chuck 2 1s in. These ones is like the size of the pixels, so I could make this different actually. You know what? I'll make this 4 and 4 for the time being. In that case, these can be more like 200 by 200. Start with a bit of a pixelized feeling, because that's kind of nice. And if that's the case, we want to demo.start. And I guess that's just initiates the onUserCreate and onUserUpdate. So even just with this now, we should have a blank program if I didn't do something wrong, which I did. I didn't include instead of define. Hashtag define. Yay! And I think it probably hasn't popped up on your screen. Let me just fix that. There it is. So we now have our blank program. It's just a blank screen at the moment, and looks like it's not visible on the recording. But in the window, tab of the window, it just shows me the name of the program, which is PixelGameEngine Hex Demo, and then the FPS, which is handy. So we'll close that for now. And get rid of that. So now it gets to, we have our base engine stuff written. Now we get into hexagons. So we're gonna have to define a bunch of classes or structs in order to, something like that, work with hexagons. Now I'm going to be referencing the Red Blob Games hex page a lot because I've never done any of this before. But basically, with hexagons, there's many different coordinate systems you can use, and he goes through, or the writer of the hex page goes through a lot of detail on the different systems you could use, and they recommend the cube system because hexagons have 6 sides, so it's kind of like 3 dimensions, and so you can sort of just look at it as a cube in a weird angle and use essentially 3-dimensional coordinates to signify a hexagon within a hex grid. And the advantage of that is that you can add, subtract, and equate those coordinates very easily, and get distances, etc. So it's very easy to write algorithms to get the information that we need. So that's what I'm going to be implementing here. And he's just put some nice, oh, I've already done something wrong. Oh, something's opening. Be gone. Okay. So I don't need this little thing here. Okay. So we're going to define we need a semicolon here as well. We're going to define QRNS, and QRNS are just variables in place for X, Y, and Z in the 3-dimensional, but just to not confuse them, it's QRNS. Why not? It's definitely good to not be too confusing with the variable names. Here we'll make a constructor which takes in, oh, something popping up again, int R and int S. I've never really used this kind of notation before, but the little underscore just indicates that that is the local variable within this function and not the same as this one up here, which is something I should definitely adopt because it's nice being unambiguous. And so here we can initialize all of our values then, so we'll just take in the values you were given and chuck that straight into our public variables. So Q becomes Q underscore, R gets R underscore shoved into it, and so forth. That's 2 underscores. And then is the wiki is the page here on implementation saying assert Q plus R plus S equals 0, and I have no idea what that is, and also my editor also seems to not know what it is. Maybe that's because it's a different language. It looks a lot like C++ to me, but I'm not very familiar with Java or any, and I know there are quite a few other languages which look similar to C++, so I'm not entirely sure what this does in terms of this keyword, but I think what this is trying to do is set the limitation or the requirement, there's a word for that, that Q plus R plus S must always equal 0. And so that actually should be 2 equals. And that's because when the main difference between a actual 3-dimensional coordinate system and on a hex grid is that if you go one step in every direction, you end up back where you were. So that's what this is trying to keep in place. So how am I going to do that if a cert doesn't work? I'm going to just quickly do a nice Google search. Cert C++. Hey, わかんないや。I have no clue. So I'm just going to ignore that for the time being and get back to it. Because that's always the best way to deal with problems. So that is all of that for the time being. And this is just going to be a structure which holds our coordinates for that hex. So that's lovely. Now we can define hexes using the hex data type, which is fun. So now what else do we need to do? Okay, so there's quite a few functions I need to define eventually to add and subtract and equate these cube coordinates for our hex grid. But I'm going to leave that aside for now, because first I want to start getting things to screen so I have something tangible to work with. So I'm just going to pop over to the browser real quickly, and there's two kind of ways I could decide to lay out my grid, either with the flats on the top, flat sides on the top, or the points on the top. And I'm still not quite sure what I'll use for the final project, and I'll probably talk with my friend a bit, who I'm working with this project on, to see what he thinks. But for the time being, I quite like the look of Pointy, and I think in my case I'm looking to make an RTS based game. So if I'm thinking of this piece and a building on there, if it's the flat one, any like modules I build off of the main building will sort of be hidden behind the main building, whereas this way they kind of go to either side, and I feel like it'll be a little bit more visually pleasing once you have a bunch of buildings connected together, some sort of module system. So for the time being, I'm going to try and code with a Pointy variation. So how do I actually do that? Well, I have now a struct which holds basically just the coordinates for Hexagon at the moment, and I'll definitely extend its functionality as we go. But of course my screen is not made of hexagons, so I'm going to need a way to convert between screen coordinates, i.e. x and y, to my hex cube coordinates, so q, r, and s. So that's what I'm going to try right now. So our first step towards getting our hexagons to appear on screen is to define our rotation. So just with earlier I mentioned I wanted to use the pointed top orientation, so we have to define that, and I'll probably define both orientations for just so I can switch between them easily. So we're going to define a helper class called orientation, and that's going to consist of a few constants, because these values should never change. They're sort of like a definition for me to reference later on. Here they're using doubles, but I'm not sure where the necessity of that comes from. I feel like an integer would be fine, but just to be safe, I'm going to go with that, because double should take double the memory, but I don't think memory is a problem for us right now. We're not making a super high intensity program. So here is the definitions for the matrix which will be our method of conversion. Very similar to the way a matrix was used when I was doing the 3D renderer to translate from three-dimensional coordinates to a screen coordinates. It's basically the exact same thing, but then we're just going from 2D to 2D. I mean, we're kind of going from 3D to 2D, but 3-axis to 2-axis, but it's only really two-dimensional to begin with. Although, in the very end, I'm planning to make it kind of isomorphic, so it will have a bit of a 3D effect, but it's essentially fake 3D. And we need a constant for our start angle. And apparently this one is defined in multiples of 60 degrees. I don't know where the hell the degrees button is on my keyboard. I'm gonna have to steal that from this website. Control paste. There we go. Just to look nice. So that's gonna be a half because we want to be starting at 30 degrees. Up here there's a very nice image. Right here. So if we're working with a system where 0, 0 is at the top left and going right is positive and going down is positive, the same way our screens on computers are defined. And I think that's also the same way that this framework I'm working is defined. So in that system, angles go clockwise from the right, around like that. So in a flat-topped hexagon, the first point's at 0 degrees, but in a pointy-topped hexagon, it's actually at 30 degrees. It's down here, because it's half a rotation, I suppose. Not quite. Anyhow, so that's why it should be half, because half of 60 is 30. So now let's define that. So now we have all of our variables. We're going to make our constructor. Orientation, which is going to take in, much like we just used before with QR and S, a bunch of all the values we just defined, but with underscores. So this is our input values, F1 underscore, double, I wonder if I can, no I can't, double F1 underscore, double F2 underscore, and double F3 underscore. And I'm just going to tab out just to make it nice and to read, but it's not necessary. B0 underscore, double B1 underscore, and so forth. And there's more. Tab out again, and we want our start angle. And now we're going to initialize and chuck all of those input variables into their constants. Sorry, brain freeze right there. And just make it pretty again. We're going to wrap this around. There is no B4. What am I doing? Or F4. And then finally, start angle. We'll get start angle underscore, which I did fail to define properly. There you go. Okay, and then we're not actually putting any functionality into this struct. We're just using it to hold information. So it just closes off like that. And for whatever reason, you always need to put a semicolon at the end of a class. Okay, and now I guess in our oops, what's going on? I accidentally built the project. But yes, so we'll be able to define our two orientations. This is just an empty orientation, and we'll define both orientations in our on user create, I suppose, would be my first intuition. I'm gonna chuck in there. Make a constant and call it it's an orientation. So we're using the orientation class. Layout pointy. And now this is our matrix, which does the converting for us. So we get the square root of 3, the square root of 3 over 2, 0, and 3 over 2. I've forgotten to put a to close my bracket. Okay, and then out here we want to chuck in our second line, the B's, which is almost the same. In fact, yeah, it's almost the same but not quite. Square root of 3 divided by 3 this time. And minus 1 divided by 3. 3, and then 0. Nope, got that wrong. The last one is 2 divided by 3. But earlier on here, where is it here? Oh no, I've done that right. So it's square root of 3 divided by 3. The minus 1 divided by 3. 0. And then 2 divided by 3. So what is that? 1, 2. It feels like there's one extra. Yes, there is. So I've done 3.01 twice. X, 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 X. And then finally, like I was mentioning before, the final one is, I've got to fix my brackets in a moment, 0.5, because we're working with multiples. That's our initial angle, and our initial angle is in multiples of 60, therefore 0.5 is 30 degrees, which is what we want for a pointy layout. And now we're going to have to, oops, fix that. Fantastic. And then finally, I just need to chuck a semicolon at the end of this. Fantastic. Alrighty, so that's our pointy layout. And you know what? I'm going to just define. It should. Oh, oops. Control Z. Should this be an on-user creator just inside of the constructor? No, definitely not the constructor. Nothing else goes in there. But I could just put it as a variable that starts on its own. I'm just going to leave it like this for the time being until I need to change it. Alrighty. So now I'm just going to copy this. So go into visual mode, copy all that, yank it. Paste. It's all just slightly off. Paste. Oops. Paste. Ah, horrible. Alrighty. So I'm going to redo that. So go to the end here, V, up. Yeah, oops, wrong side. Yank, down. There we go. Paste. Oh well, good enough. Okay. Now, what have I done wrong here? For some reason, the semicolon disappeared. Here as well. Okay, and then I'll just make a blank line there. Now this time we want this to be I consider that one word already. Over here, instead of pointy, we want flat. So Shift R, flat, and then just XX. Now what do we want to change? We want to change most of it. First of all, this whole square root disappears, and instead we just want 3 divided by 2. Then we don't want the square root of 3 divided by 2. We just want 0. And then we don't want 0. We want the square root of 3 divided by 2. And then just the square root of 3 in the next one. So we can square it and then get rid of this. Yes, square root of 3, that's correct. Alrighty, next line. First of all, the square root can disappear. Instead we just want 2 divided by 3, which is that now. 2 divided by 3. And then we just want 0. Next we actually want minus and then 1 divided by 3. And then finally the square root of 3 divided by 3. Epic. Got some errors going on here, so let's fix those. I've got a lone bracket here, we don't want that. That's fixed everything. Fantastic. So let me just confirm this. We got 3 divided by 2, we got 0, we got the square root of 3 divided by 2, we got the square root of 3, we got 2 divided by 3, we got 0, we got minus 1, we got 3, we got square root of 3 divided by 3, and then finally this 0 should no longer be 0. Sorry, this 0.5 should not be 0.5, but instead just be 0, because now we're starting at 0, like I showed previously. And that should be it. Like you see, all the values probably not the same. It's probably just reorganized slightly. I would like to properly understand the mathematics behind that at some point, but for the time being, we're just gonna use these very happy little black boxes. And that is our orientations. If I need to move that elsewhere in the program, then I can easily copy and paste that. And now what we need is the layout class, which will be where we actually store all our hexagons, I believe, and are able to draw them onto the screen. So, after orientation, I'm going to make another struct called layout. The word layout feels a little bit weird for me, and I may consider changing that to something like grid if that's appropriate, but I still don't fully understand what it means or what its purpose is. So let's figure it out. First we gotta get our orientation. And oh, it looks like for this it's using another struct called point. Now I haven't defined this. Let's see if it, yeah, it's going to give me errors. Alright, I'm just going to finish typing first, and then I'll define that function separately. just as all the previous times, we're just chucking in some values into our constructor and then defining those values, or initializing them, I guess. Computer's a bit slow for some reason. Oh shit! It's been on my browser this whole time. I hope that wasn't too long. Fuck. Oh well. At least my voice would have been getting through. So here's where we are now. Just defining the orientation, the layout class, and initiating our variables. Okay. And we have our semicolon. So let's go define our point class now. Our constructor, and we'll be taking in a double for our x and our y, and then initializing them. I don't know if that's actually what you call this. I should double check that. That there, but we do need that down here. What's going on here? Doesn't like my YW, Y underscore. Why is that? Why? Y underscore. Y underscore. Why is it unhappy? It says it's not defined. 定義されていません. But silly me. I have forgotten to define its class. So I was just calling a variable without ever defining it. Okay. So that should be all for my point class. It has just occurred to me, I wonder if all these have to be inside of my olcEngine class. I don't think so. And if it is a problem, I can always change it. Okay, so now it's the time to actually create a function which will convert our hex coordinates to a pixel location. Now, where should I place this function? My guess is inside of hex. So I'm going to do that for the time being, but it may not be the case. In fact, no, it definitely isn't. I'm just going to define it on its own. So I'm going to go down here and just give it a bit of space. And this is going to return a point because it's the point on the screen. And I'm going to call it hex2pixel. Hex H. They've got it in the the hex grid guide as H, but I hate having short names, so I'm just gonna call it hex. So this is using a pointer address, but I'm not entirely sure what this means. Let me just think about this quickly. So it's making a constant which is of the orientation class M, I'm assuming standing for matrix, equals the layout dot orientation. Now if we go back to layout orientation, it's defined here, and that's from this up here. So we're looking at probably either the F or the B's. My guess is the F's. Yeah, so it's the first 4 of that matrix of the orientation class. Okay. Next we've got a double for X and Y. It's going to be m.f0. Yeah, f0 times hex.q plus m.f1 times hex.r. And we're going to times that whole thing by the layout size dot size dot x. Okay, so we're basically just doing vector matrix multiplication. So m dot f 2, I guess, times hex dot q plus m dot f1 times hex dot r times layout dot size dot x. Josh. Okay. And then finally we're going to return our point, but we're going to take this x we just defined, but now we may not want the start of the grid to be in the very top left corner, so we're going to add our layout dot origin dot x and also the y. So yeah, it's actually makes a lot more sense. So we're taking our values from the orientation, which has got our matrix and scale and the translation inside of it, and we're just taking our coordinates from the hex, so Q and R in this case, and and using this layout to convert it to our pixel value, pixel location. So first we times it by the matrix, each part individually, x and y. That's basically just matrix, vector matrix multiplication. So the x part gets times by the x base vector, and the y gets times by the y base vector. And then it gets scaled or transformed by the size, and that's if we wanted to change the, if it would, for instance in my case I probably won't want it to be exactly uniform. To give a bit of an isomorphic fake 3D feel, it'll be squished a bit, so I'll be able to do that with this size variable. And then once it's been transformed, we can translate it to wherever we want the grid to be on the screen. So yeah, the layout is essentially the grid, I guess. Oh, not quite actually, no. The layout's just storing all of the values we need in order to lay out the grid. Fantastic. Okay, so in this layout class, the f variables, which we just used, is the 4 components of the 2x2 matrix to convert from hex to pixel. And what the b values are is just the inverse matrix of that, these b values. So we can use that to write a pixel to hex function, which will be useful for selecting hexagons with mouse, etc. So we're going to make another function right after this one called pixel to hex, and it's going to take in the exact same. Actually, no, it's not, is it? This time it's going to take in the point of the mouse, or whatever, a unit. So we're going to have, then needs a capital, layout, and then point, and in this case, yeah, point is a bit long. I'm just going to write it for readability. Alrighty. Now, we're basically going to do the exact opposite as just before. So before we multiplied it by the matrix, then transformed it, then translated it. So in this case, we have to do the opposite. So first we're going to translate it, or untranslate it. Which, actually even before that, we need to first get our matrix. And then we take away the translation. So we got point. What we just did here at the very end with returning that point, instead we make the point first, take in the x, so point dot x minus m layout dot origin dot x and point dot y minus layout dot origin dot y. Next is getting the translation, sorry, the transformation, the scaling, and looking at the guide I realized I can just do that in the exact same line. So I'll check some brackets around these. simplified the whole thing by layout.size.x. And that first detranslates it, and then untransforms it, untransform. You get the idea. And just the same thing, but wider. Now I could bring that out, but it all fits on the screen, so I'm just leave it as. I've done something wrong here. We're missing something. Hello, helpful. Am I putting too many? No, that looks right. I don't think we should change anything, but just to make it readable, check that like that. Does that change anything? Looks alright. What's going on? Why are you complaining? It wants another one of these. But it shouldn't need it, but if I chuck in another bracket, yeah, of course it doesn't work. So what's your problem? Oh, I haven't actually defined, the name of the function. Will that fix things? No, point pt equals point. That would be it, would it? Still errors. What to do? So I can't seem to find any obvious solutions, so I'm just going to keep on writing a little bit and see if anything clears up as I continue this. So we just need to get our now we're going to do our matrix multiplication, which is timesing pt by the inverse matrix. Now I could have said, defined separately like I did in the 3D renderer, a vector matrix multiplication function, but here we're just doing it manually, and I don't think we'll have to do vector matrix multiplication very often, at least not to the same extent, so it should be okay. Dot x plus m dot b1 and do the same for r. That's what I've done. There you go, that lines up. And then we're gonna return fractional hex. I suppose because this could output a float. So there is a class I forgot to define, which true, this doesn't return a point anymore, does it? It returns a fractional hex, which then gets rounded to an actual hex value. But I have not made it a fractional hex function. So sorry, class. So let's do that. For some reason, it's still not giving me an error for the fractional hex here, but I definitely haven't defined it anywhere else. Oh. I was already searching it up. Yeah, it just pops up once. So I'm just gonna, oops, copy this one. And yank that. Paste. Alrighty. And fractional hex. And now we just want to change, the only thing we need to change is this. So 1, 2, 3, and float. 2, 3, and oops. And this one too, xxx, put in float, xxx, and we want to float. Okay, that should be everything for that one. I just realized this is completely empty at the moment, so I'm just gonna chuck this back here. Oh, this is actually maybe the one time I'm ever gonna actually want to use Shift J, which just gets rid of the concatenation or whatever. Perfect. Beautiful. Okay. And I accidentally just built it again, but it's not. There's an error up here. Expected a bracket before float. Oh, so I'm not happy with that white space. It's still. Ah, it's because I haven't changed the constructor. So that'll be a fractional hex. Sweet. That shouldn't have any problems. Oh, it's actually running. It's still giving me an error here, but I have no idea why. コンストラクターのインスタンスが因数リストと一致しません。で、どういうことですか? It's not the same same. The instance of the constructor is not the same as the list it's pulling from, something like that, but it's doubles. It wants doubles, but it's not getting doubles. Is that its problem? So point.x, because points is defined as a double. Let's see. The point is defined as doubles, but the input is also a point. I don't understand where the problem's coming from. Looks like it's running anyway. Let me try and get rid of all this unnecessary dialogue. Run it again and see what errors it gives me. So no errors, that runs with no problems. Let me just fix the program so you can see it. There it is. It's just a black screen still. But it runs. But what's it telling me? Pixel to hex. Warning, no return statement in function. All this is saying is that I haven't got a return statement at the moment, so I had forgotten to write that. And that's just going to be returning a fractional hex. So return fractional hex. And that's going to have Q, R, and then minus Q, minus R. And that's just creating a hex, but because when we're doing calculations, we're not using S, but the hexagon actually has three axes, Q, R, and S. But S can be easily calculated with minus Q minus R, coming from the rule that Q plus R plus S must always equal 0. Therefore, S equals minus R minus Q. So that's that. It's still giving me a strange error here, even though it runs perfectly fine. So I'm a little bit confused. If I run this again, no, now it's giving me a proper. Oh, this is a me just forgetting a semicolon. Silly error. Runs fine, 0 errors, but in editor it's giving me a strange error. Saying that it's drawing a double. 54, 5. But something's not a double. Point.x is definitely a double. Well, point.x. Yeah, no, it should be fine. X is a double, Y is a double. And the construct, no, that's up here. Point. These are doubles, and the constructor are doubles. Well, I'm just going to ignore it for now, because it's not causing any problems. Maybe it's just a problem with my editor. Which is unlikely. This is probably something I'm doing wrong, but it might not become apparent until later on. Okay, so I've just been doing a bit of reading, and I think the last thing I'm going to do today is get some hexagons drawing on the screen, because it'll be something tangible and exciting to look at. So I'm just going to follow the guide to write two functions. One of them is to find the 6 corners of a hexagon, giving a center point. And then the other one is to find, one of them is to find the offset, and then the other one's to find the corners. So we've got a function which returns a point, which is hex corner offset. And that's going to take a layout and corner. So it basically, we feed it in the layout we're working with, either the point top flat or top point topped or flat topped, and then also which corner we want, and it'll give us the offset from the center of that corner, whether it's the top right corner, the bottom left corner, the left corner, the right corner, whatever. So it's a pretty short function. First we take the size from the layout. So we get define size, and that's equal to layout.size. So we just pass that value straight over. And then we've got the angle, which is going to be 2 pi. Here they have m underscore pi. Oh, it's there. Interesting. I guess that's how pi is defined in C++. And then times by the layout.orientation .start angle plus which corner we're dealing with divided by 6. So what we're doing here is pi over 3. I don't understand why we're doing 2 pi over. It could just be shortened to pi over 3, I think. But let's just go with this for now. I'll try and simplify it later. But pi over 3 equals 60 degrees. So what we're doing is we're starting with our offset, which is either 0 or 0.5, a start angle, and then adding a corner. So it'll either be like 1 times 60 degrees, 2 times 60 degrees, 3 times 60 degrees, or half times 60 degrees would be 30 degrees, 1.5 times 60 degrees, etc., etc. And that's what's going to quickly give us all 6 angles we need. But right now we're just doing for 1 corner, so this is just the maths to find that offset. And so then we just return a point, which has size.x times cos of our angle. Good old trigonometry here to save the day. Size.y times sine angle. And so that's going to just convert our rotation around a circle of a certain radius into, the size.x and size.y is our radius, and we're just timesing that by, well, size is our radius, size.x and size.y, I guess, is just the components of that radius, and then we're timesing it by angle and sine cos of our angle. Okay, then the last function we'll need is a vector of points. In the last one, when I was working on the 3D renderer, that was when I got introduced to how vectors as like lists are built into C++ are defined and used. And I kept on getting confused between the built-in vector, which is like a list, and the vector 3D structure which we'd defined. So, but I guess you can use it for pretty much everything, anything the vector data type. Alrighty, hex. Alrighty, now in our vector, first we're going to define a variable, which is a vector which is going to hold like a list of all of our corners, all 6 of them. And we're just going to leave that empty for the time being. And then we're going to retrieve the center by using our function that we defined earlier, function hex2pixel, and we'll put in the layout and the hex, which gets chucked in. And that'll just very simply return us the center that we need. And then we're going to define a for loop. In Python, it would just be for this in this, number and number, but here we actually have to define our conditions individually. So we've defined I as the corner number, I guess. Now we're going to grab that offset from the function we just defined before. X corner offset. I'm going to chuck in our layout and the corner number. And then once we have that, we're just going to push that to the back, push back, which is the same one we used last time, I believe, in the 3D renderer. Point center.x center.x plus offset.x to .y plus offset.y. Don't forget semicolon. So that's just gonna go through for all 6 of our corners and grab their offsets, add that to the center, and so we have 6 coordinates on screen in our pixels for drawing on the screen. The very last thing we have to do is return the corners. Okay, so that's when I stop looking at the hex guide, and now I'm just dealing with the olcPixelEngine to draw some hexagons. So I'm going to jump over to on user update, and from here I'm kind of on my own, but I guess first thing I have to do would be I have to find our orientation. I need our corners, starting from the end. I'm just going to draw line. And it takes a vector 2D. I wasn't able to get the vector 2D to work properly, the built-in one. So I hope there's a legacy way of defining a line. Looks like there is. Draw a line x1, y1, x2, y2. Okay, nice and simple, just defining the 2 points. So it would be taking in, this is a bit more, I think I have to define another function first. called draw hex, and that's going to return, I suppose, just true or 0. So we'll just say int draw hex, and then say hex. Yeah, just do that for now. And that's going to return 0. Before that, we're going to say draw line, I have to draw 6 lines. So first we need to get the points. So polygon corners. So I'll say vector points corners equals polygon corners layout, yeah, just layout hex for now. So I'll need to change this a bit. I will need a layout. So I get the corners, and then I'll go into a for loop. For I equals 0, I is less than 6, I plus plus. So I just want this to happen 6 times for each line. And in here is where I'll have my draw line. So sorry. That was because I was inside of it before, but now I have to say olc draw line. Can I just not access it? In here it pops up because it's inside of the olcEngine class. So I might have to chuck this draw hex and cut that. Throw that within the public here. So before user create, cool, draw hex. Now, am I able to call the draw line function? Yes, okay, fantastic. Draw line, and then we're going to be dealing with corners. So corners, and it'll be starting with 0. So I dot x how am I going to do this? 1, 2, 3, 4, 5, 6. Yeah, no, I should be able to do this. So I dot x corners I dot y, and then corners I plus 1. So the next point along, dot x, corners, I plus 1, oops, dot y. And that will, if I've done this right, so it's going to go through for 6 times, and it's going to draw a line between the ith corner and the I plus 1 corner. And that'll go from 0 to 5, so that'll be first corners, second, third, fourth, fifth, sixth. It feels like I'm still missing something, but let's just try and run that and see what happens. So on user update, we want to, oh no, I'll have to make a hex first. So how do we call this function? It'll be draw hex, and I've already defined a layout, so we'll say layout pointy. Yeah, so I've done these in the wrong place. I can't access them. So where should I call those? I'm just going to do them public for now, but maybe they should be in private. So that's not going right. I'm just going to do this manually. Oh, actually no, this just needs to come up. There you go. Okay. Now let's try and access that. So on user layouts pointy. There we go. Now I can access them. Layouts pointy, and then the hex. So up here as well, I'm going to have to define a hex. But draw a hex. Can I just say hex? Hexagon. And equals hex 0, 0, 0. Okay. Now I'm still getting some errors, but is that just still that weird error there? I'm gonna just try run this. What the hell is gonna happen? Errors! How lovely. Errors that don't pop up in the error, the editor. So the first one's at line 70, so let's jump to 70. Polygon corners. Vector was not declared in the scope, so do I have to add something, include something to enable to use vectors? I think that may be the case. Let me just check back on my old code and see what I included. So yeah, it looks like I need to include something. Apparently vectors are included in the standard library, but I'm just going to implicitly include vector. Let's see if that solves some issues. Okay, of course this is getting cluttered, so I'm going to rebuild that with a fresh terminal. Some lovely errors. Back in 70 again, do some 71. Vector does not name a type. I think what it is in the last time I was using vectors, I was using the namespace std. This time I'm going to not use them because it's nice to be explicit. And was there somewhere else I made a vector? Std vector and yeah, std vector. Does that fix some problems? Need to clean my terminal again. Yay, I think I stopped getting vector errors. Okay, so we can move on to the next one. Points is not a data type, you are very right. Control F, points, oops. Points, there we go. So this should not be points, just point. And same thing down here, just point. And down a bit further as well. Here, I did vector points, but that should not be that. And vector points, and I feel like I forgot to do std up here. I did. So std vector. Does that fix some problems? I'm going to clean my terminal again. It's annoying it doesn't reset automatically. Oh, it's getting shorter. Now I've got a problem with my for function. So on line 109, oops, 109, for I I've forgotten a semicolon, simple mistake. And here, int, I forgot to say int. Just lots of little mistakes after one after another. Now 127. It's kind of fun. It's like searching for all the errors and slowly bring them off one by one. Layout underscore pointy. Cannot convert. That's an area orientation, not a layout. So do I need to define a layout? Yes, I do. That's what I've forgotten to do. So I've got an orientation, but now I need to define a layout. Layout. I'll just say layout or hex layout, and equals layout, and then chuck the stuff in. And what was it that I needed to chuck into a layout? Here it is, struct layout, and the layout required an orientation, a size, and an origin. Perfect. Let's do exactly that. So where we define our layout, first an orientation, so we can just throw in the layout underscore pointy. Size, I'm just going to put a random number like 10, and the origin will also be something like, oh no, it has to be a point, doesn't it? 10, 10, so I'll define that first. Origin, layout underscore origin equals point. I'm forgetting to put the point at the beginning, but let's say 10, 10. Point. That was not what I wanted to do. Here we are. I have to copy this and paste it right afterwards, changing point to size. And then say layout underscore size, layout underscore origin. Okay. Now let's try. Still getting errors. No, this actually should now change to hex layout, was it? Yes. Hex underscore layout. And hex is not hex, it's hexagon. Ah. Okay. And bug hunting again, let's go. First 110. Unqualified token. Because I chucked in wait a minute. My bad. I just changed some things unnecessarily. These are within the function. The place I'm actually defining it is down here. So this now becomes hex layout. $110. Same place. I haven't fixed the error apparently. I didn't get rid of this. There we go. Now it's 104. Oh no, yes. It's getting shorter though. Slowly getting there. 104. Before point, I'm forgetting semicolons. And here as well. So, anywhere else I'm forgetting? Let's just leave it like that for now. Just one error. Oh no, a couple more. 133. Another forgetting of a semicolon. And no return statement in 134. Oh, because it was missing this. Let's just try that now. Is this going to run? I think it might. Whoa. My computer is frozen. Whoa. This is no good. Computer is completely frozen. Okay. Oh, something happened. Okay, I have some movement. Whoa. Oh, it opened. Oh, we have something. Not sure if this is coming up. Program olc. This is what I'm looking at. So we have something that looks like a hexagon. That actually looks a lot like a hexagon, but it's missing a very important part. It's for some reason going back to 0, 0. Whoa, my computer is dying. I'm going to close that now. Okay. Ah! Sheet. Visual Studio closed itself. Visual Studio Code. Okay. Sorry about that, technical difficulties. Okay, there we go. Visual Studio Code is back. So I'm obviously doing a lot in terms of, I don't know, it's not very happy at the moment. I might change a couple of things with the size. I'm gonna make it not as pixelated. 1, 1. And increase the size a bit, 400, 400. And I'm gonna change the center. Should check it's still appearing properly on the screen. Yep. I'm going to change the origin to 200, 200. Which is exactly in the middle, and keep the size. The size looked alright. Actually no, we want to make it a bit bigger, so say something like 50, 50. And it looked like this was not doing what it was supposed to do. So it was going 0, but the last one was going to 0, 0. Let's just try it one more time with the fear that I may crash everything again. It seems to be running fine. Oh, that looks a lot better. Things are running without breaking. And so we have a hexagon. That's amazing. We just one corner. Oh, you can't see that. Let me put it up. So we have a hexagon. Looks a bit small and a little bit buggered, but well, it's not quite a hexagon just yet. So we're almost there. It looks like it's starting there. But then the last one is not going right, I believe. Why would that be? So assuming it starts at here, at this point, it goes up there to 1, 2, 3, 4, 5. But the last one is starting from 0, 0 to here for some reason, is my analysis of it. Let's try and fix that. So something wrong with our draw hex function. So because what happens when it's at 5? When it's 5, this is 5, 5, and I plus 1 would be 6, 6, but there is no 6. Is that what the problem is? So 5, 5. What's I minus 1? If it starts at 0, no wait. So 0, but 5, it'll be 5, 5, 5 plus 1 is 6, and there is no 6th one. So how can I fix that? It needs to go back to the beginning, to the first one. This is kind of a weird way to do it, but I'm just going to make this go 1 less. And then once it's gone through the for loop, draw 1 last line. But this time, corners 5 dot x, corners 5 dot y, and then back to 0, corners 0 dot x, corners 0 dot y. That needs to become corners and don't forget the semicolon like I always do. Okay, that's a really ugly fix, but let me see if that does what I want it to do. Hey, we have a hexagon. What success! All this work for a single hexagon. And if we wanted, I'm pretty sure we could change the color pretty easily. We just have to go in here and add one more argument and say something like olc, oops, red. The last one's not going to be red though, but yay! We have an almost fully red hexagon. And now just as a final test, get rid of the white. Now what happens if we change the size? So 50, 50, not 50, 50, but 50, for example, 30. Will that make it into the nice isomorphic kind of orientation that I'm wanting? Yes! Look at that! So now just imagine we're having a nice long, nice grid of these, and buildings and units will be able to go on top of them. Alrighty, well I think this video's gone long enough already. It's already almost 2 hours. It's the longest one I've done so far. And this had very little result, but we have a beginning here. We have most of the code we'll need to do this, and in the next one I think I'll be able to start getting some grids, and maybe even getting to the point where I can save those grids in a map data. And once I have that infrastructure down, also I want to try and get to the point where I can select hexagons, and hopefully to the point where I can add and remove like base plates, imaginary buildings by clicking the mouse on hexagons or selecting hexagons. And from there I'll be able to actually start doing building mechanics. So yeah, thank you for watching as always. This is exciting. I'm really happy to be working on this. This is a project, well, the beginning of a project that I've been wanting to get into for a long time. So I'll leave it there. Thank you for watching, and I'll see you in the next one. Have a good night.